Hi, today we're going to be having a look at this brand new but faulty Chefman Turbo Fry Touch Air Fryer. Now I saw this on eBay for spares or repair and it was just pretty much paying for the postage for it, so it was actually free. It was only the postage and I paid around £7 postage for it. So what I'm going to do, I'll get it out of the box. I'm going to try and fit it on the bench. I'm having to use a different camera at the moment because the overhead one's just showing just part of the top of the box here, so hopefully I can get it all on the bench. We'll plug it in, see what it's doing, and hopefully repair it. Right, I'll get it out of the box then. So, this is the unit out of the box. And if I just pull the drawer out here, I'll just get it under the camera so you can have a look. You can see, it's never been used, it's brand new. So let's plug it in and we'll see what it's doing. Right, got a power lead there, plugged in. Little indicator light there. So we'll plug this in. And absolutely nothing. So I think the first thing we'll do is we'll check this fuse with the meter just to make sure that the fuse is intact. Let's get this fuse out. Actually, I could probably just check it without taking it out. Well, let's just have a look. And it's a 13 amp. Yeah, the fuse is okay. Let's pop that back in then. So I wonder if we get any resistance just across the live and neutral. We've got nothing at all here. Just got the resistance. Yeah, we've just got meg ohms there. So I'm wondering if there's a wire came off inside, if there's a safety switch or some kind of thermal fuse possibly. Well, I'm sure we'll find out. Right, let's see how this thing comes apart then. I'm just going to take the drawer out first. And let's have a look, see if we can see if there's any screws or anything on this. It doesn't even look like that heater's even been hot at all. I can see a couple of screws, or 4 screws just along this very edge here. But I would have thought the top's going to have to come off somehow. Let's see if we can get this top bit off. So I can't zoom out. Well, I can zoom out a little bit more on the camera, but not a lot. And because this is reflective, it's messing with the light settings. So I'm going to try and get a spudging tool or something just to see if this top part comes off here. I'm back with a spudging tool. Well, that bit does move a bit. Let's try another spudging tool, so you can get 2 under here. It's the only thing when all these new appliances now, they're all clipped together. They're not really designed to be taken apart. I wonder if I can get a bigger screwdriver on that. Well, it definitely doesn't want to budge. Just going to see if I can get that in there for a moment. Right, I think I've just made a little bit of progress there. Right, so this is clipped. This looks like we've got 1, 2, 3, we've got 5 clips. So there's 1 at the back and there's 2 at the front here. And what I did was I poked the screwdriver in a bit here and kind of pushed them back while levering up. Right, let's see how we'll get into the rest of it now then. I'm just having a look here because I have got a different view of what you've got. So it looks like we've got 1, 2, 3, 4 screws here. A couple at the front and there's 2 little ones at the back here. I'm not sure what they're for. Let's take those out. I'll put that on one side. Right, does this bit come off or not? No. Well, this looks like the main power board here. We've got a relay. Looks like a little switch mode power supply. I mean, the fault could be on there. And where the power comes in. This looks like it goes to the front panel display board down here. So where does the mains come in then? I guess those ones go to the heater. Right, it's going to take a little bit more investigating this to see how it comes apart even more. ACN, so AC neutral, AC live, right. So what I might do then, I might just unplug these two here and we'll see if we've got continuity from here to the plug. Right, we'll do that. I'm just trying to think of the safest way and easiest way of doing this. Let's turn that little torch off there. So let's go into continuity. And here's the plug. Let's make sure you can see the meter there. So ACL. So these got a little tab you've got to press in to release them, maybe. So some appliances do. Yeah, I think these ones have. Now whether or not I can actually press the tab, because there's heat shrink on, I can't even see the tab. Let's take the little board out. Then we don't have to disconnect them, we'll just measure on the bottom of the board. And I am unplugged. Right, so AC neutral is this one. And we have continuity from there to there. Let's try ACL then. And we've got continuity from there to there. So that means we should have power to this board. So why isn't anything lighting up? I was just thinking it might be something like a thermal fuse or something, but I guess not. Not if we're getting power to here. Because I would have thought at minimum it should just light something up on the front or something. Let's see if we can figure out this little power supply here. I've got a little 0 ohm resistor there. I wonder if that's blown. Let's just double check. You can still see the meter there, so that's good. No, that's okay. Because sometimes they use as little fuses. You've got another, I think that's a 0 ohm resistor, I can't quite see though. Possibly not. That just looks like it's for controlling the triac in any case. Well, I can't see anything obvious up to now. That's actually got some stuff written on here. So what have we got here? That's just letters. I thought it might have had something like 5 volts and whatever, but it doesn't look like it has. Not sure what those two are. I guess it's going to be some kind of temperature sensor. Those two little white ones there. and the other ones just go to the control board on the front. So I wonder if we need to get the control board out next. So one thing I've just noticed here, we seem to have a little bit of a safety interlock switch here. So I wonder if that's working. So we've got two wires coming to here, and also this black wire which seems to go down the bottom there. So I wonder if one of those is sort of like a safety interlock. Let's just have a go measuring those. So we're going to here. Let's try and get the wire in there. So we've got about 9.6K there. Let's try and get the meter in shot of it. I'll just try and press this button in. Well, that's not doing anything. Let's just try these black wires. Try and get the probes on there. And we've got about 335K on there, so. Right, so it looks like those two black wires go to this safety interlock switch at the bottom here. So that appears to be working. Right, I'm going to try and get this front display out just to have a look over that. And it looks like we might be able to get it out by these 4 screws here. And I think there's a couple of screws just underneath this part here as well. I'm not going to be able to get my screwdriver down there though. It actually looks like this whole front section comes off because there's some screws down there, but they look a bit of a nightmare to get into as well, I think. I'm just going to have a quick look over just to see if I can figure out how this front panel comes off. So this whole front panel display is held in by these clips here. There's 8 of them all together, 2 at the sides here, which is the ones that I first started trying to get out, and I think I did the ones at the top. Lever the panel forward slightly and the bottom ones just came out. So let's have a quick look over this board then. Well, we've got an IC here, which is probably the main processor, which has just got A1640 written on it. And quite a few 0 ohm resistors dotted about. This is the main cable coming in from the power supply unit, and it looks like we've got serial clock, serial data, 5 volts and ground. And we've got an IC here that goes to this connector here, which I guess that's going to be some kind of touch controller then. And it's also got here serial clock and serial data. So that's probably a touch controller, I would hazard a guess at. So let's see if we get any 5 volts on these 2 pins here. Right, I'll just zoom out a bit so you can see the meter as well. Let's get these wires here. Right, I'm just going to plug this in. Right, so this is now on. And let's see what we get on these pins here now. Yeah. Well, I can see the power supply sort of pulsing on and off there by the look of things. And that usually indicates there's a short circuit or something somewhere. It's like the power supply is trying to start up and then shutting down. Right, I'm just going to unplug it again a sec. Let's see, I think the first pin was ground and the second one was 5 volts. Let's see what happens if we poke the probes in there and switch it on. So So we've got 5 volts. That's not looking good. That kind of indicates that there may be a short on this board here. Let's just hope it's not another. I can't be dealing with another microcontroller shorted out. That would not be good. I mean, it could still be a problem with the power supply. I wonder if I can put something on here, some kind of load. I'll tell you what I could do. Let's just measure the resistance between here and here. 35 ohms. Well, that's not looking very good, is it? Right, I think what I'll have to do now then is I'll try injecting 5 volts on here from the bench power supply. We'll get the thermal camera out and we'll see what's getting hot. Please don't be that chip. I'm just going to tin these pads a bit first. I mean, hopefully it's going to be a capacitor or something. As I haven't had much luck lately with microcontrollers and things being blown. It'd be good if it was a capacitor, because then at least I can change the capacitor. If it's the microcontroller gone, well, what can you do? Right, let's just hook up the bench power supply. So I've got it set to 5 volts at 200 milliamps. I'm just going to grab the thermal camera. Just wait for this to switch on. And that's just where I've been soldering there, which is a bit hot. Right, let's put some power onto this. And let's see if anything else starts getting hot. And it's dropped the power right down to 2.5 volts, and it's drawn the full 200 milliamps. Right, I'll just switch this off. We'll just crank the amps up a bit. I'll just go to 1 amp. Right, let's see if that does anything. And it's dropped it right down again. What's that? That looks like it could be the problem. I'll just find something to point with. And that is the centre of this chip here. Well, it's not the microcontroller, but seeing as we don't know what that chip is. Right, I'm just going to switch this off a sec. And I'll just switch the thermal camera off. So this is the Kuwait's KTIW02, and if you want one, I've left some links in the video description along with the discount code. So this IC here, now I don't know if there's any markings on this, but at least we know where the fault's located now. So what I'll do, I'm going to get the rest of the unit out of the way and we'll get this under the microscope and we'll have a look. See if we can identify this chip. Right, got it under the microscope. Let's just try putting a bit IPA on here. And just try cleaning this off with a cotton bud, just to see if there's any numbers. Let's try focusing that in again. Well, I can't see any numbers at all on that. So that's not good. So how many pins have we got? So it looks to be a 20 pin IC. It looks like pins 12 and 13 are serial clock and serial data. Looks like pin 10's the power supply. And I guess pin 9's ground. And it does appear to be some kind of touch controller, so I wonder if we could possibly find it by using that information. But what I may do is just try and remove this chip first, because we don't know whether the microcontroller has been damaged as well. So I might try removing this and then powering it up just to see if the short's gone. And then we can also see if anything lights up on the display, which it still mightn't, because it may, one of the first things this chip might do is try and communicate with this chip to initialize it. And if it doesn't get a response, it might just hang there, you see. So I'm going to have to remove this glue stuff or whatever first, I think. Or silicone or whatever. Let's get this little dental pick and we'll just try getting rid of that. I don't know what's caused this failure. Whether it's just been a faulty chip or something, or whether static or something, I don't know. It just seems a bit unusual for the touch controller to go. Right, I'm going to remove this board from the housing and then I'll heat it up with the Rework station. Right, I've removed the board from the plastic housing because I didn't want to melt that with the hot air station, but what I might do is just use some low melt solder, which is this stuff here, and if you've not used it before, I'd highly recommend it. It's great for removing things like chips and USB sockets and things. So I'm just going to put a bit of flux on this first. Right, we'll just get the iron out. I'm just going to run some of this low melt solder across these pins and the same at the top. I'm just going to grab a pair of tweezers. I wonder if this chip's glued or something, because that should be off by now. Unless this has got some kind of no, it shouldn't have a thermal pattern because it looks like there's tracks going underneath it. I wonder if this has been glued on or something, this chip, because it doesn't seem to be budging. And all the solder's melted. I did have a little screwdriver knocking about somewhere. Where's that gone? Let's try this one. Yep, there we go, glued underneath. I thought it must have been glued or something, because they don't normally take that long to get off, especially with low melt. Right, I'll just clean this up a bit. I'll just get some more flux on here. I'll just grab some solder wick. I'll just clean that up with a bit IPA and a cotton bud. Right, that'll do. So I'll hook this back up to the bench power supply and we'll see what happens now. Just before we couple the bench power supply up, I just thought we'd check the resistance just across these 2 points now. And we seem to have K ohms now. So the short has gone. Right, let's couple this up. I'll just flip it over a little bit and let's just power it up and see if it does anything. Well, it's not drawing any amps. And it's showing 5 volts. But I wonder if it's this interlock switch needs to be shorted out or something. I'll just see if I can find a jumper or something. I could use a little bit of solder, I suppose. Let's try not to short this board out here. Actually, I could just use these just in case it's something to do with the interlock switch. But it could well be that the processor is stuck in a loop trying to communicate with the touch chip, or it requires you to press something on the front to send a signal to the microcontroller for it to switch on. Well, it still looks dead as a dodo. So I spent quite a bit of time seeing if I could find out what chip this is. I was looking at different touch interface chips, you know, that was SOP20, and I couldn't find anything that sort of matched this pinout. So I thought I'd get the scope on it and I'd see if there was any signals coming from the MCU over here. So what I've discovered as well is I thought this said A, because that looks like an R there with the little line. It looks like, I thought it was A1640, but it's not. It's actually AIP 1640. So I've decided to look up that number, and this isn't an MCU. What this is just a display driver. So it drives LED displays, 7-segment displays, and other LEDs on the board. So that means if this isn't the MCU, it means that this chip here is the MCU, which obviously contains the program to make the thing work. So without this chip, even if we can get this chip, we haven't got the program to program it to obviously fix this. Hey, trust my luck, isn't it? It's like this is about the third device now that I've had which has had MCU failure. You just cannot make it up. So I'm not sure whether we're going to be able to fix this or not, because unless we can get a replacement MCU or a replacement board, then this is going to be it, unfortunately. So I'm going to see if I can have a look around, see what I can find, and then we'll take it from there. So I thought I'd have a bit play with the display board, because I found the data chip for the display chip, and I hooked it up to an Arduino board here to send the clock and data signals into the chip via where they go to the microcontroller here, because I traced through the board. But unfortunately it did absolutely nothing. So I think this chip is also fried. And so I found some example code and it should have worked. I even had the scope on the clock and data pins to make sure that the Arduino was sending the data into the chip, but not a flicker. And I even tried the test mode for the display chip, which should switch on all of the outputs, and the display still did nothing. So I thought, well, what could have caused both of these chips to fail? So I thought I'd have a look back at the power supply board here, just to see exactly how that works. So I started reverse engineering it, and I found out something a little bit interesting about the heater control side of it. So we've got this connector here, and that's the pinouts of it there. We've got ground 5 volts, heater control, which comes from the microcontroller, a control pin that controls the fan via this little triac on the back here, a pin that goes to this little buzzer here, and the last pin at the end here goes to this socket for the NTC for to sense the temperature. So let's have a look how this works then. So instead of just switching a signal either high or low to turn the relay on, what they're actually doing is a little bit clever. They're using a pulse width modulation signal or a clock pulse from the MCU, which then goes through a capacitor and then gets rectified back into DC and then charges up this capacitor here. And the reason why they've done that is because if the MCU crashes, for instance, and the signal's just left high, it just means the heater would just continuously heat up and probably set the thing on fire. So this way, the MCU signal has got to keep toggling up and down for actually keep the relay switched on. So the signal goes through this cap, gets rectified, charges up this cap here, So this cap blocks DC, so if it's stuck high or stuck low, nothing will happen. This cap gets charged up. It goes through this diode and through this resistor and switches on this transistor here. And it also switches on this transistor here, which switches the ground through to this side of the relay coil. This side's got 5 volts across it, and that energizes the relay. And we've got a little diode across the back of it here, just to stop back EMF when the relay switches off. So that's how that part of the circuit works. And I reverse engineered the power supply bit as well. So we've got the mains comes in here. It goes to a little capacitor here, a little filter capacitor. And we've got 2 1 meg ohm resistors across that capacitor. So when you unplug it, it discharges this capacitor through those resistors. Otherwise you could get a little bit of a shock if you touched the plug. So that's what those 2 resistors and that's capacitors are for. The mains then comes down here through this 22 ohm resistor, through a couple of diodes, and charges up this main smoother cap here. It then also goes through an inductor and then charges up this main smoother cap. This then goes to this little chip here, which is a PN552L. Now I couldn't find a data sheet on this, I couldn't find really any information on this chip, but it looks like a little offline buck converter. So we've got about 300 and odd volts comes in on this top pin here. This must have some kind of MOSFET inside that then switches that voltage through this inductor here. So this is acting like a buck converter. And it then drops it down to 5 volts, which then goes to the output. We've got a smoothing capacitor, a little decoupling capacitor, and a 510 ohm resistor just across the supply as well here. So what I think may have happened, I don't know whether this chip's had some kind of spike or something, and instead of regulating the voltage down to 5 volts, perhaps it's shot a higher voltage through here and into the MCU. And that's what I think possibly could have happened. Now when I've tried the power supply, I am getting 5 volts out of it. So I'm not sure what we'll be able to do about that. If there's some kind of crowbar circuit or something we could add as a safety measure to stop this from happening again. Because I've checked all the components on the power supply and they all look okay. I mean, that's pretty much the little circuit here and the little inductor. This 600 microhenry inductor. There's this little thing here. I thought it was a transformer at first, but it's just an inductor. Anyway, the good news is I've managed to find a replacement control panel on eBay, and that has just arrived. So this is the replacement control panel here, and I'll just bring the listing up, and a big shout out to the Rebel Appliance, who was very kind enough to send it a bit faster for us, so I had it to finish off the video. And if we just look at the back of it there, it's exactly the same as the original one. Apart from what I've done, I've soldered a 5.6 volt Zener diode on here to act hopefully as some kind of crowbar circuit. So if the voltage exceeds 5.6 volts, this diode will either clamp the voltage down or short out, hopefully tripping the power supply out to prevent further damage. So hopefully it'll save the MCU in case anything like this happens again. So I've just put a couple of wires in here, and I'll just couple this up to the bench power supply, and we'll just check that the control panel works. And I'll have to just use my tweezers here just to short out the safety interlock thing. We'll just flip the control panel over and I'll just power it up. And as we can see, this panel seems to work. So let's put it back in the unit and hopefully we'll have a working air fryer at the end of this. Let's get this power supply back in first then. So this one goes to the heater. And you've got the AC neutral. have this one goes to the fan, and this one is the live in. Little NTC to go back in. And I'll just find a couple of screws to put this power supply back in. Might as well unplug that and we'll use the cable that came with it. Let's get the new front panel in. Just move this forward slightly. So not quite the repair I was hoping for, but I wasn't expecting it to be the microcontroller that had failed again. Definitely not the repair I was expecting, or the fault I was expecting. Well, it just goes to show you, you never know what the fault's going to be until you actually get into something. That's the front panel back in. Let's get this top bit back on. And hopefully that should be it. Right, let's plug it on. Well, that looks promising. Excellent. I think that's it. But what we'll do, we'll give it a proper test and we'll see if we can cook something in it just to make sure it's working okay. So I'll just get this out of the way a moment. And I just want to bring this board back in a second. And the failed chip. Let's just zoom down a little bit. So, main microcontroller failed. And I think it's probably through over voltage. So I get a lot of comments saying, well, why don't you just buy a new microcontroller chip then replace it? Well, I think I've actually found what this microcontroller is. Because it's had the numbers removed, I did manage to find a chip that's got the same pinouts of this. So I'll just bring that up on the screen so you can have a look. And if we notice, we've got the ground pad goes to this one here, and the 5 volt goes to the end here, and it's also got all of the touch keys coming from these pins along the bottom here that go to this connector here. So I'm fairly sure that it's either one of those two chips on the data sheet here. Now the problem with microcontrollers is you can't just read out the program. Even if this chip was working, a lot of them have got what's called code protection, which stops you from reading the actual code that's inside the chip. So it's not just like an EEPROM where you can read it, flash chip or whatever. This has actually got code protection, or a lot of them have. I mean, nearly all microcontrollers have got code protection on them, and that's why you can't just read the program out and program it into another one. So you're kind of held to ransom with the manufacturers to that, unfortunately, because they're not going to give the code away that makes their product work or makes their product unique. So that's the reason why we can't just copy them. And we can't repair items like this unless we can get a replacement board or a replacement microcontroller from the manufacturer. Right, speaking of chips, we're in the kitchen and I've got some southern fries here. So let's switch it on. I'll pull the drawer out and we'll put some of these bad boys in. I think that'll do. Right, let's get that in. And we've got a fry setting. So is that it then? You need to set the temperature or anything. I've not used this before. I think you just hit fries and then start. Right, well we'll leave that to do its thing and then we'll come back once they're cooked. And we've just got a couple of the cats on the windowsill there. That's Hunter and Giz. I think they're both rescue cats that we ended up getting. And just to the left here, you can see the KitchenAid mixer that I worked on in a previous video. And that thing's built like a tank. It's the most reliable appliance I think I've ever bought. Right, let's come back when this is a bit further on. So it's been running for about 5 minutes now and it's just started flash and shake. One thing I have noticed as well, on the camera it looks like these are sort of pulsing, the flash and the time temperature button. But they're not actually in real life. I think it's just some kind of shutter effect with the speed of the camera compared to the speed of the multiplexing of the display. Right, we'll leave that for a bit longer then. And it's just flash and shake again now. There's 10 minutes left. I think these are almost done, to be quite honest with you. I think they're probably just done now. So let's get them on a plate and see what they're like. Nice big plate of fries there. I'll just switch this off. Nice. A bit of tomato sauce there as well, on the side. Right, let's see what these are like then. Crunchy. Right, I'm going to enjoy these fries and hopefully you like this video as much as I like these fries, and I'll see you in the next one.